Welcome to all joining us today. My name is Adele Kroch and I'm from Food Focus. And once again, I want to thank the Dairy Standard Agency for providing us with the information and the speakers and sponsoring this talk today. The main purpose of the DSA is to promote and improve the quality of milk and other dairy products to the interest of the consumers and the industry. And one of the projects of the DSA is information and education. And the webinars that they've been hosting this year cover all these aspects and topics. And today's webinar is yet again another good example of this. Today's talk is about key areas of hygienic design, discover the importance of the critical aspects to food safety in the dairy industry. We have two presenters today and I will introduce both of them and they both will present, and then after that we will have a question session. The first speaker that I would like to present to you is Peter Muguefu. Hello Peter, welcome. We're looking forward to your presentation. And Piet Grobler. Hi Piet, welcome. We are really also looking forward to your presentation. So just a little bit more about Peter. So Peter is a lecturer at the Department of Consumer and Food Science at the University of Pretoria. He teaches modules including product development and quality management systems, meat science and dairy technology. He's also currently enrolled for his PhD in food science at the University of Pretoria. He holds a Master of Science degree for Food, Nutrition and Culinary Sciences from Clemson University in South Carolina. His research interests are meat science and animal protein. Peter worked as a senior food technologist at Limpopo at Agri-Food Technology Station at the University of Limpopo for 5 years. In the capacity, he trained agri-food businesses on food product development and food safety practices. As you can see, Peter also belongs to a number of professional organizations. He's got memberships at SAFOST, SASDT, IF, and AMSA. So that is Peter, and then Piet Grobler is a qualified chemist with 35 years of experience in providing hygiene and food safety solutions to the food and beverage industry. He collaborates closely with various stakeholders from farm to fork in the food and beverage industry on aspects pertaining to food safety, application chemistry and validations in the dairy industry, and drafting of national standards in chemistry, hygiene and food safety. Piet also belongs to and a chair of different associations, the SASDT and Earheads, and OFT Group, Head of Hygiene and Food. So there's the whole pedigree of the two awesome speakers that's going to present to you today. And with that, I'm going to hand over to you, Peter, for your presentation. And we are really looking forward to your presentation. Thank you so much.
Thank you, Adele. Good morning, everyone. Well, I'm going to start off the presentation under key hygienic design areas. First, I will talk about today's agenda. The first up, we'll talk about key hygienic design areas, then microbiology and food safety incidences, microorganisms and equipment surfaces. Pete will talk about the introduction to EH services and capabilities, hygienic design and food processing as it relates to machine areas, hygienic design and food processing as it relates to processes, hygienic design criteria, surface geometry, welds, shafts and couplings, drainability, top rims and covers. So I'm going to start off by just talking about what could happen to your business if a food outbreak incident takes place within your organization. But first, let's look at the key hygienic design areas. The key hygienic design areas covered by EH include hygienic building design. This will include hygienic floors, walls, ceilings, drains, and zoning. Food defense, such as site security, heat, ventilation, air conditioning, cablings, ducts, and cabinets. Under hygienic utilities, water, stream, and air quality, hygienic equipment and process design, material of construction, hygienic welding, maintenance, cleaning and drainability, cleaning and sanitation, cleaning in place design, dry cleaning, cleaning out of place, open plant cleaning, cleaning procedures, cleaning validation, cleaning and sanitation chemicals, and then personnel hygiene, gowning, hands, shoes, cleaning devices, and then personnel hygiene culture, the hygiene practices within an organization. Now I'm going to talk about what could happen to your organization if there is a food outbreak, food disease outbreak. So here I just gathered a few examples from around the world. This relates to Ferrero chocolate, which is linked to multi-country Salmonella outbreak. So here, nearly 100 people are thought to be affected in the United Kingdom, in Ireland, in France, in Germany, Sweden, and the Netherlands. So what's happening here is that this company, Ferrero Chocolate, is now linked to Salmonella outbreak, and this damages the brand. It damages the company brand, and they are selling a product that is, this product is marketed to children. So you can imagine what the consumers are thinking because of a food outbound. And then another example is from Blue Bell Creameries in the United States. This company was ordered to pay 17.25 million in penalties. This was in connection with Listeria outbreak in 2015. And it's a company that produces different types of ice cream and other dairy products. The CEO of the company was charged. He eventually resigned, but he was still charged. And this case went through the court systems until I think it was 2020. And then it was eventually thrown out in 2022. So from 2015 until 2022, they were going through litigation because of the Listeria contamination in their factory. Another example is an Italian official to find source of deadly Listeria outbreak. And here, 2 people died of Listeria outbreak linked to cheese. Italian official reported 33 people have been affected with 2 deaths because of this outbreak. And this was in Asiago Pressato cheese. My last example is from England. In England, E. coli outbreak caused by milk pasteurization. And this one relates to hygienic design much more closely. This was an outbreak of E. coli 0157 in England, affecting 20 people. And it was thought to be caused by milk pasteurization failure. And as you can see here in red, a sample of pasteurized milk from Darwin's dairy failed the phosphatase test, indicating contamination by unpasteurized raw milk. So what happened is that there was a damaged seal on the flow divert valve. And this is something that a good hygienic design could help avoid. So this was just a highlight of what could happen to your brand, to your business. It could cause people to be sick. You've seen that in other places, people were arrested, charged, and companies had to pay money because of this outbreak. Now, next I'm going to talk about microorganisms and equipment surfaces. So here is an example of what happens when microorganisms have taken over in an area. So here is irreversible biofouling on reverse osmosis membrane, and this has survived many cleanings. And what happened here is that a biofilm has formed and it has clogged these pores in this reverse osmosis. And as you're cleaning throughout, the biofouling is not removed. It stays there and it hardens. Another example is in the heat exchanger. You can see there's massive biofouling there. It has covered the heat exchanger. It makes it inefficient over time. So why are microorganisms such a big foe and they're causing such havoc around the world, as the examples that I've shown you indicate? Well, let's look at the surface roughness of your stainless steel. So a typical representation of stainless steel surface roughness should be less than 0.6 micrometers, and this is achieved by 240 grit mechanical polish. And there should be no surface defects or damage according to the EH standards. Okay. So here we're looking at a representation of the surface, and we zoom in and we see that microbacterium could be at a size of 1 micrometer by 0.2 micrometers. And if there's a defect on the surface, that microorganism can find a way to hide in the crevice or in any defect that was caused on the surface of the stainless steel. So that's why it needs to be less than 0.6 micrometers, and it should be polished smooth enough with no defects, because if there are defects, those defects could be used by microorganisms to hide. And then eventually, if one microorganism can hide there, they can divide very quickly, and within a week, they could form a biofilm. So there's this saying that it's, looking for these microorganisms is like looking for a needle in a haystack. And that's actually true, because if you look here, I have a representation of a needle, and this is the pointy end of the needle, and this is magnified at 141 times. And if we look into the next picture on the right, magnified at 1123, we still cannot see those microorganisms. If we zoom in again, this time we've magnified it to 4,494 times. We still see that there's something, but we don't see the microorganism. It's only when it has been magnified to 17,974 times do we get to see that there are some bacteria cells in there. So you can imagine the foe is hard to see. It's impossible to see with naked eyes. So therefore, we have to have different techniques that we are applying that can eradicate it. So why are they so successful? Well, it's because of the way they divide. They will divide very quickly within 4 to 20 minutes. Even some would have divided E. coli, maybe even within 20 minutes, they have the next generation. And then they have different modes to survive. They could form a biofilm, and that could help them survive harsh conditions. They would exchange genetic material to help them. They adhere to surfaces. So if one cell, like the one I showed you earlier, could adhere to a surface, within a week, there may be a biofilm in that area. If there's moisture and nutrients, then they will grow and form a sort of like a covering, as you saw in the heat exchanger example. You can find this microorganism on processing equipment surfaces. They will colonize stainless steel, rubber, all the way up to Teflon. If the surfaces are exposed to frequent cleaning, so constantly cleaning, as I mentioned, within 20 minutes, there's a next generation. So if there's frequent cleaning in the environment, then we could minimize or at least control their adhesion to surfaces. They would use surface attachment, and then if the microorganism attached to the surface, then they have enhanced resistance to chemicals and disinfectants. So they adhere to the surface as you're cleaning and washing over the area. Because they've attached themselves to the surface, they are able to resist the chemicals and disinfectants that you're using. And I will talk about the mechanism they use for that. Some of these microorganisms can cause corrosion. I will explain that a bit later. So I mentioned biofilms. What are these biofilms? Biofilms are a layer of bacterial microorganism colonies. They are associated together, and then they form an inert surface attached by a matrix of complex polysaccharide-like material. And then in that area, they're able to trap nutrients, and then they're able to resist different types of cleaning that you would be using within that particular area. They start by attaching to the surface. And then after that, they will release this extracellular polysaccharide, which will help them stay and adhere to the surface. They will form a unique environment of different species in that area, and then they will increase resistance, and then even up to 1,000 times resistant to sanitizing chemicals or sanitizing agents. They don't necessarily increase heat resistance. And then Teflon will be easier to clean because it's much more innate than stainless steel. And then in that biofilm, as you see here on the right-hand side, new microorganism will come in and attach as you are cleaning. Water and your sanitizing agents are just passing over the biofilm. They go over it, and at the bottom here, microorganisms are staying in there, exchanging genetic material, becoming more resistant to whatever chemicals you're using. And then over time, they could behave like a tough plastic film. So they toughen up because they're releasing these polysaccharides. They would toughen up and form glue-like substance, and it will be as though they are glued to the surface. So therefore, it makes removing them very difficult. So advantages of microorganism being in a biofilm, well, it has been said that about 90 to 99% of microorganisms were in a biofilm or are in a biofilm at one stage or the other. Well, that's because within this biofilm, there's a concentration of nutrients. This concentration of nutrients is increased at the surface. There's decrease in turbulence and scouring. There's a diffusion of exoenzymes is decreased. They don't have to release enzymes to degrade other cells around the environment because they are in a friendly environment that is mutually beneficial. There's mixed species within that environment. At the top, you will find that there are aerobic microorganisms. Towards the end, anaerobic microorganisms are in there. Possibility of communication through quorum signaling. They will send signals to each other to alert each other about the environment and about the population of the microorganisms. They will transfer genetic material, and when they're transferring these different genetic material, they increase resistance within that particular environment, so they become very difficult to clean. They are protected from bulk phase environment, and then they will be able to resist different detergents, sanitization, and even antibiotics over time. So that's why you'll find them in most of these microorganisms will be found in a biofilm, and this makes it very hard for them to be eradicated. So here I just want to explain biofouling, and on the left-hand side, we have an example of a biofilm that has formed on a surface, and in this case, this biofilm will cause biofilm corrosion of, for an example, stainless steel. And they do so, there are different types of bacteria that you will find within this environment. They are both aerobic microorganisms that require oxygen at the top, and at the bottom, you see that they are anaerobic microorganisms, and they will cause corrosion of iron and stainless steel structures by sulfur reducing bacteria, and you also have iron reducing and oxidizing bacteria, and then this will cause corrosion of stainless steel due to the differences in charge in the stainless steel. And you also may have acid producing bacteria that will produce sulfuric acid, acetic acid, nitric acid, and this will corrode the metal. So eventually this biofilm, the formation of a biofilm, will participate in corrosion of that stainless steel. Now on the right hand side, I'm showing an example of, let's look at this. So on the left hand side of the diagram on the right, there's a scale of thickness of the surface of material. Let's say it's your stainless steel, and here we're showing millimeters in thickness of the material. On the right hand side is reduction in heat transfer. Okay. So when a biofilm has covered perhaps your heat exchanger, it will lower the energy efficiency or the heat transfer with 1 millimeter will lower up to 50% in heat transfer. So it increases energy cost compared to, let's say it's ferric oxide in red. It will take up to about 5 millimeters of ferric oxide covering perhaps your heat exchanger to reduce its efficiency by up to 50%. But with the biofilm, that takes only 1 millimeter. So it just shows you that they are very effective in reducing the efficiency of your heat exchanger, or at least heat transfer. These are other examples of microbiologically induced corrosion on a heat exchanger here at the bottom. That part that you see on the left-hand side, it just shows what the biofilm has done. It has caused corrosion, and on the right-hand side, you can see how damaged that heat exchanger is. It now has pits and crevices, so it's totally damaged. My last slide, my last two slides, here I'm going to talk about hygienic design as it relates to shelf life. On the left-hand side of this graph, you have concentration of microorganisms. And then at the bottom side in the x-axis, you have raw materials that you're receiving. They're going through processing, and then there's a heat treatment, and then eventually processing and packaging. And then we're looking at this best before date. There are two lines. The first line at the top, it's talking about the microorganism limit for consumption. That means the microorganism have to be reduced to be underneath this line for the product to be suitable for consumption. The line at the bottom, it's about microorganism limit for packaging. That means during packaging, you want to make sure that the microorganisms are lower than that line. After pasteurization, when you have applied pasteurization, you received your milk perhaps from your suppliers, and you apply pasteurization to that. You reduce the microbial load with bad hygienic design at the top. You reduce the microbial load during this heat treatment with your pasteurizer. And then over time, before the best before date, you see that you have there's enough microorganism to surpass the limit. And this is with bad hygienic design. With good hygienic design, you apply the heat treatment and it reduces the microbial load to such a way that you can take the product and it will have low enough microorganism to be good enough for consumption by the best before date. This is when you're applying pasteurization. In my last slide, this is when you're using sterilization. When you're using sterilization, the same slide, when you apply heat treatment, you have eradicated the microorganisms. This is with good hygienic design, and the product will be good by the best before date, virtually with no microorganism. However, even if you're using sterilization and there's recontamination, and then contamination could be from during filling, it could be the air in the environment, it could be anything that happens particularly during packaging of the product. If there's recontamination, and then the chances are that the microorganisms will grow enough, and then by the best before date, you will have just too many microorganisms, and in that case, your processing would have failed. This is my last slide, and I'm going to hand over to Pete, who will continue the presentation. Pete, over to you.
Thank you so much, Peter. Very informative discussion to set the tone for the discussion, which I would like to share with the audience. Ladies and gentlemen, on behalf of EH South Africa, I would like to thank you for the opportunity and thank you for making time to discuss a very important issue. I believe is very simple. If you look at the slide that I'm presenting, is that the EH mission is to enable safe food production by providing guidance as an authority on hygienic engineering and design. And our view is that whatever we do is proactive in ensuring that food that we produce is safe for the consumer. Just on EH, on the it's really an organization that was founded in 1989 as a non-profit organization, and it's really funded through a growing number of committed members. And I will just share with you some of the facts around the EH organization. You'll see our vision is really to be recognized as the leading source of hygienic engineering expertise, and that is expertise globally. If you look at our geographical areas, if you look at our geographical presence, you'll see that we significantly cover the globe, with recent activity around just before the COVID outbreak. Is we then set up the regional section for Africa, and based in South Africa. Our product portfolio is really about 10 key focus areas that you can see there. And Adele has alluded to that. From the DSA perspective, is training and education is a critical part thereof, hence our involvement in this webinar. Just around our services and capabilities, EH is about training. It's about certification, where we certify specific equipment. It's networking, discussing relevant topics with leading experts across the globe. And we also have working groups that actually put together guidelines that I will cover a bit later in this presentation. So just to what Peter has spoken about, the key hygienic design areas, when we look at that, is from hygienic building design, it relates from everything from the floors right through to cabling. And I don't want to go into too much detail, because obviously there's a lot of information related to this. Hygienic utilities, hygienic equipment, and process design, and that is where we'll spend a bit of time today, just highlighting some key issues. Cleaning and sanitation is obviously always critical. CIP design, EH has a guideline specifically for written for CIP design, for example, and then personal hygiene. Right, so when we produce food, obviously we want to do it as hygienic as possible to ensure that the food is safe for consumption. Aspects, cleaning and disinfection requirements, the building and services, and then also the process and utility requirements, where we talk about zoning, etc., flow of product, flow of people, etc., that we obviously need to cover and ensure that it's done in the best possible manner. So when EH talk about product contact surfaces, there's just a couple of definitions that we need to talk about. The first thing is we talk about direct product contact surfaces, and we refer to indirect product contact surfaces. So when you look at our diagram here, at the bottom we have our product. We have here, for example, lights that can or soiling from lighting that can contaminate our product. Steam from the ceilings itself. Water, we can condensate, obviously. Then lubrication, any lubrication, because somewhere the product will be packed and moved from one area to another. There's lubrication involved. There's air, and then obviously from our containers itself, or our packaging, or even our food processing surfaces, that is obviously direct in contact with our product. That is critical. When we look at our different processes, we have what is defined as open processes, where the product and the product contact surfaces are exposed to the environment around the equipment. So when we talk about processed food facilities, that is typical. Majority of those processes we would see as open. Then we'd also have closed processes, that is, product and contact surfaces are not exposed to the environment necessarily around the equipment, but obviously it is exposed directly to the equipment. Now, in some processes, for example, in dairy, you have a combination of open processes and closed processes. Hence, it's very critical that we understand what the risks are and how to mitigate those risks. So from equipment certification perspective, what Earheads would do is there's equipment class 1, and that is equipment that can be cleaned in place and be cleaned without dismantling. So typical valves, those type of equipment will be certified. And then if we talk about class 2, it's equipment that's cleanable after dismantling and be freed from soil after reassembly. So obviously we do not want recontamination. And Earheads has different standards in terms and guidelines in terms of how to get equipment certified. So when we look at our hygienic design and food processing, open processes. Now here just have some pictures of open processes. The product is, although in some cases very limited, but the product is in contact with the environment, and the environment we said is anything relating from the ceilings to the lighting, etc., that can actually cause contamination. Often it's large product contact surfaces with very complex geometry. So if you have a look at if you look at the geometry here, one can just think how difficult it would be to ensure that those surfaces are clean and disinfected to the correct standard. The design of equipment plus the environment must prevent any increase in soil and microbial concentration. What we imply here is obviously there's a process in terms of getting surfaces clean, which will entail the removal of gross soiling. It would entail then the applying a detergent. It would imply removal of the detergent and the soil residues, and then obviously a disinfection step where we ensure that our surfaces are clean and adequately disinfected. From the closed processes, this is a typical example of a dairy. You've got your bulk tanks from where you would transfer the product into the different sections, be it pasteurizers, be it sterilizers, be it packaging, etc. So in terms of the guidelines, there's specific guidelines. They're all numbered 8, 10, 13, 22. That takes into consideration all the requirements from a hygienic design to the point where the guidelines is, or the preferred method of processing, cleaning, etc., relates to the type of product. So when you've got a liquid type product, the requirements would be significantly different to when you have powder-based products, for example. So on the hygienic design and food processing, when you talk about general requirements, drainability, absolutely very key. We know that wherever there's water, there's opportunity for microorganisms to grow and to contaminate, be it our product, be it surfaces or contact surfaces, be it direct or indirect. And drainability is critical both in terms of open processes, in other words, processed food, specifically processed food, but it's also very important when you start talking about CIP applications, as any stagnant water in CIP in product lines can actually cause contamination. So drainability, very important. Sharp edges and corners, I'll talk about that a bit later, but obviously if there's sharp edges and corners, there's opportunity for soil and water to accumulate. Cabinets that need to be sloped away from the product, no overlap joints, welding specifically to joints that needs to be sealed, avoid soil and microbial buildup. And that is one big issue is, again, it comes back to adequate cleaning and disinfection and adequate design of equipment to ensure that all surfaces are cleaned and disinfected properly. Should that not happen, there will definitely be some microbial buildup because of residual soiling. Make it close if possible. Obviously, we don't want our product exposed, so where we can, as far as possible, keep tanks and other transfer equipment, our transfer tanks, etc., keep that closed, and keep the food items covered. So when we look at the surface geometry, when you just look at shaft ends and couplings, we've just got some diagrams here. So typically, what we have here is, and we've just marked it A2 just to ease of reference, is you've got metal to metal contact here on this coupling. So obviously, where there's metal and metal contact, there's an opportunity for soiling to actually penetrate that. There's exposed thread here. So when we look at what are the requirements when you look at couplings, for example, is a domed screw head, a metal-backed gasket in that area, domed nuts, radius. So in other words, as we said, we don't want to have any sharp edges, and then seals, obviously where we need to, where surfaces actually join. This is just an example of what it should not look like. When we look at these different covers, again, this is just an example of the covers themselves. So when you look at the blue is the product area. What we have here is we have a hinge and we have dead ends. There we have a sharp end. Yeah, we have a dead end. Obviously, areas where soiling can accumulate, right? So better alternative for typical covers would be that it's not fixed, but it's rounded. Yeah, we have a specific hook that allows us to lift it and lift the covers, and then also in this where you've got a self-draining cover. So obviously from a surface geometry, these are some important aspects when it comes to covers. When you look at welding, we've got overlap sections. In this area, what we have is we have a step here. So obviously we've got an area where soiling can accumulate. This is our product area. The A is our product area. There's the step. So an improvement would be to have a sloped edge, and obviously we want continuous welding. This is what this demonstrates, and we do not want intermittent welding because obviously it also then creates crevices where we can have issues and problems. When we look at conveyor belt design, if we look at a typical framework, overhanging belt, then you've got your cladding, and the important part, you've got your stainless steel table, and the important part is that this is not fixed. So in other words, we have a overhanging, a release tension that we support roller that we can swivel into that area. So obviously that makes the cleaning and the conveyor belt so much easier. We've seen it in a number of new designs, or not within the food industry, we see quite a lot of these belts becoming more and more prevalent in the industry. There you can see somebody just cleaning the surface. There's the belt lifted from the area, and that helps cleaning underneath the belt. When you talk about seals specifically, again, we have our product area, and we have a elastomer seal, and then we've got a protruding seal, and there we've got an area where there's a crevice. So obviously, during our cleaning process, you'll have accumulation of soiling here in this area, and also you will start having accumulation of soiling in that area because of the crevices created. When we look at some cleaning challenges, especially in closed systems, we talk about systems where we don't need to dismantle, or we don't dismantle to clean specific areas. And what are typical problems we're experiencing is, if you look at this spray ball here, with that area at the top there, that gap there between the metal, obviously as soiling actually enters those crevices, then obviously with the cleaning process, it will be very difficult to remove that. Also, in terms of dead legs, when you look at tanks where we have specific sections joined to the tanks, and that in its own creates some challenges, as there might be a number of dead legs in that instance. I was talking about drainability. So the important part is that the exterior and interior of all equipment must be self-draining or drainable. Obviously, if it's self-draining, so much better. And it must be easily cleanable. We have the saying that if we cannot see something, we can't clean it. And if we can't clean it, the chances of soil buildup and microbiological fouling and microbiological buildup is obviously imminent. Hence the importance of making sure that during the design phase or during the implementation phase, because a lot of these items can be designed correctly, but it's not installed adequately or properly, that also can cause some challenges in terms of cleaning and sanitation. So surfaces should always slope away from product. In case of external surfaces, slope away from the main product area. And this is just an example of lids that actually, there you can see there's an incline of one piece, whereas in this case, you have all these different areas where soiling and microorganisms can actually enter and cause problems in terms of our product. When we look at vessels, vessel design obviously very important. In this case, we have the outlet quite above the what's the area, above the bottom of the tank, and so draining becomes a problem. Same with this picture, where you have this welding into, or this section going into the tank with its outlet there. You actually have areas of accumulation or non-draining areas there. Importantly is to have these curves, etc. So there's a whole host of designs that will allow drainability from vessels itself. When we look at horizontal surfaces, there's residues of soiling there because it's a horizontal surface, and there's a very small clearance. So the recommendation would be to have a clearance from a fixed structure of greater than 300 millimeters, and that will allow accessibility to actually clean these areas. And then obviously the sloping also assist. From a ceiling perspective, should it be close to, and this is a wall area, should it have to be against the wall, obviously one can seal that to prevent soiling to penetrate those spaces. When you talk about closed systems, the welding requirements, we were talking about welding earlier in open processes. This is, for example, typical closed processes where you have piping. There are two guidelines. One is specifically about the requirements of good welding of stainless steel, and then there's also a validation section as well. So welding requirements, obviously it needs to be freed of edges. You obviously don't want misalignment, as that will just cause areas where you can have problems, yet you're at the bottom or even at the top if you don't have the correct flow. And then this is concavity. Obviously, again, there need to be certain limits. This is greater than 10% is unacceptable. When we look at an acceptable weld, this is typical what an acceptable weld would be. Here is an illustration of lack of penetration. So again, you would create a crevice, which in itself can give problems from a hygiene perspective. Here you can see a photograph of an inside of a pipe that was welded, and from our experience, you can have excellent welding from the outside when you look at the piping from the outside. However, if you actually take an endoscope, etc., look inside in the interior part, you will, if the welding is not to standard, you will actually notice quite a number of areas, risk areas, that needs to be mitigated. When it comes to key pieces, the major issue would be to avoid dead legs, and this is typical flow of product or flow of cleaning solution as well. These are fine. Yeah, in these two illustrations, you actually have dead legs. In other words, those are areas where your detergent and disinfectant does not come into contact with those surfaces, obviously harboring microorganisms, soiling that can give a number of problems when it comes to shelf life, when it comes to product quality, and any other parameters that we're measuring. So this is really in terms of the summary, and it's just taken from the guidelines. We talk about the definition of ideal hygienic weld. There need to be full penetration, no cracks or pores. There mustn't be a misalignment, no lack of fusion. All these aspects that is addressed when we talk about the finish itself of stainless steel. The presence of pores obviously provide areas of concern when it comes to hygiene. We talk about what happens during the cleaning. So in other words, very specifically cleaning processes, cleaning methodology that we actually, in terms of requirements, is what do we specify as the correct operation to, for example, do CIP cleaning. It will depend on your soiling, it will depend on your processes, but there's very clear guidelines. The zoning on your factory is how we should be zoning our factories when we design factories, or even when we do renovations to existing factory. Pumps, what are the advantages of the different types of pumps that we use? Why are some good for for product transfer, others not. What is the importance of installing pumps correctly to ensure there's no dead legs or stagnant areas where we don't have transfer of product or cleaning detergents and disinfectants. So this is just a host of the modules that we actually cover. Goes in very in depth in terms of hygienic design across all those parameters that we discussed about. So it relates from direct contact surfaces right through to indirect and aspects and of importance and actions that we need to take to ensure that we mitigate any risk that we might have. Just from a EH perspective, should you wish to just go and look at what EH is all about, what we're offering, there's a whole host of media that you can go and view. There's newsletters, there's our website, eh.org, and there's a lot of information available. Some of it is free downloading, others need to be procured. So just from a regional section in South Africa, we would really welcome opportunity, as Adele mentioned, and the DSA is about knowledge transfer, and regional section South Africa is certainly behind those activities to ensure that the industry is informed. We also have an advanced course in hygienic design, which we present through the University of Pretoria. And this is a typical example of the certificate that will be issued should you write an exam and pass. And then there's just my contact detail should you wish to discuss any specific matter, and our secretary for EH South Africa, Ann Wallace, you can contact her. Any questions?
It seems like both you and Peter have done such a good job with your presentation that there is no questions currently being asked or written in the question bar. So please, everybody, if you want to ask any questions, now would be the time to do so. So I would really appreciate if you would ask if there's any questions. So we'll give the people a few seconds to see to it if there's any questions from their side. But one thing that's very clear for me is, I mean, Peter, even in your presentation, you spoke about biofilms again, and the DSA have had another webinar that specifically also just spoke about biofilms. And if any one of you have missed that, you can go to our website, www.foodfocus.co.za, and you will be able to see the recordings there. But my point that I want to make is that very often people get their results, their micro results, and they've got a problem with microorganisms and they do not know where to start. And definitely with the presentations, both from your side, Peter, and Peter from your side, it shows how important design is. So from what can you basically do for any small business? So if I'm a small farmer and I now have got a my own business and I've got challenges, how can you support and help the smaller people in terms of the design of their businesses?
Yes, Adele, what the guidelines specifically do is it gives the user very specific and clear guidance. Remember, these are not standards. These are guidelines that's been written by experts across the globe, and those guidelines are very specific in terms of how to go about to the point where how to set up your factory from scratch, if I can call it that. So from the construction right through to the equipment gets covered through these guidelines. And then we in South Africa have obviously a number of standards, and we have industry experts that can assist. But what this does for me, it just brings everything close, where people have one stop where they can get the relevant information and yeah, and do what's necessary to, obviously, two things is, and I mentioned it during the presentation, is to provide food that is safe to the consumer, and then also do it as effective and efficient as possible.
Absolutely. Piet, you're talking about these guidelines. How can the people get hold of these guidelines? Where do you present these guidelines?
Okay. People can actually visit our website, www.ehs.org, and they can click on guidelines. And there are some guidelines that is downloadable from the website. But there are others, more specific guidelines that needs to be either procured, or companies that wish to become members of EH actually have access to that. It forms part of their membership. They then have access to the guidelines, the whole list of guidelines.
Wonderful. I've got one question that came in, and someone's asking, will you recommend a rough surface for a scullery area?
Definitely not. So the rougher area, it's always from a cleaning and disinfection perspective, is the smoother areas are, the better it is to clean, and it does not, it's so no. So rough areas is really not.
Yeah, and I think Regulation 638 is actually quite clear about saying that all surfaces must be smooth, cleanable, and yeah, rough, definitely not cleanable. I think in terms of safety, making it non-slippery, there's other ways and means of ensuring, because the scullery area is normally very wet.
Yes.
And I assume that's a reason for the questions. But for that, they can rather put in grids, am I right? Or what other type of safety aspects for non-slip?
So grid, there's a number of international companies, actually EH members, have some very good standards on, for example, flooring and drainage specifically. So again, there will be a guideline that can give some assistance to that in that regard.
That's awesome. It seems like we don't have any other questions. Piet, thank you so much for your presentation. I think it is so important for everybody to go back and literally all these small snippets that you've provided them in terms of design. I'm sure of it, there's people out there that have premises that's quite old. And, these are the things that you would need to put on your priority list to make sure that you don't create your own problems. Piet, I've got one last question for you. What is the aim of the EHEDS that you've now set up, the regional section that you've spoken about? What is their biggest aim? I know you said it's in terms of getting people together, but what is the main aim?
Okay, yes. So we set up EH because of the acronym European Hygienic Engineering Design Group. The view was from the market was it's mainly European, and so EH took a strategic decision to spread globally, and one of the shortcomings was they didn't have representation in Africa, and hence we started the regional section in South Africa. And the aim is really to fully support the local market in all aspects of producing food that is safe, and also to produce it in a as hygienic way as possible. Again, we are collaborating with international companies that has a presence in South Africa. We obviously collaborate with them, And then we also collaborate with the institutes like the Pretoria University of Pretoria, also to get the information and also to get the knowledge transfer from an early age to the students actually at university level, so that when they actually enter the industry, they already have a very good base of what do we mean when we talk about hygienic design. What is the importance? You know, how do we do fault find, etc., etc. So this, it really gives the industry and everyone involved a very good focus area going forward, which we had to some degree, when we have to some degree, but this is just an additional information and additional way of looking at matters.
Perfect. Peter, Piet, thank you so much for your time. We really appreciate, and for everybody, the presentation as well as the recording will be available on our website, www.foodfocus.co.za. So most probably tomorrow, you will be able to see the recording, and also both the presentations will be a PDF download. So if you've missed any of the other webinars, please make sure on our website, under the resource button, we have got a button called webinars. And if you go in there, you would see all the previous webinars that was hosted and sponsored by the DSA for you to ensure that you better the quality and products of the dairy industry. So there's also going to be another webinar on the 13th of September, and there we're going to speak more about pasteurization to the next level. So make sure that you look out for the social media and the newsletters where we promote this. And also, if I can ask you, after the webinars close, there's a small, a short survey. If you can please answer those questions, we can appreciate that. Yet, Peter, thank you so much. Have a lovely day. And to the audience as well, have a blessed day and go well. Thank you, Piet. Thank you, Peter.
Thank you very much, Adele. Thank you, Peter. Bye-bye.
Bye-bye.